Okay, so the last question I've been asked to go through so far is question 10. Just because of the way I did question 9 there, question 10 I've run out a bit of space, so I've just moved it across here. So we'll work through from there. So question 10 has an exponential graph, and they're always a little bit confusing when we're trying to find the equation. So we'll have a go at that. Okay, so a graph shows the population growth in a certain town from 2000 to 2015. P, which is our y-axis, is the population of the town in thousands, and T is the number of years after 2000. So the first question it gives us is A, what is the population in 2002? Well, 2002 is 2 years after the year 2000, so we want to go to the x value of 2, and you can see there we've got, been given in the question, a nice little couplet of numbers that applies to that period 2 years after 2000. So we can just use that and we can say, well, when t equals 2, that's the most terrible t in the world, there we go, t equals 2, p equals 5.02, so therefore the population is 5,020, because remember it says here this is the population of the town in thousands. So if we've got 5.02 lots of 1,000, we just take 5.02, multiply it by 1,000, and we get 5,020. Fairly straightforward, that first question. So B, using the exponential model, y equals k a to the x, write the equation of the population growth over time. Now with exponential models, you've got to understand that you're going to have to use the x value of 0 and then use whatever other value you've been given. So in this particular case, we know that when x equals 0, or t in this case, when t equals 0, then the population equals, it looks like it's hitting right there at 4. P equals 4. So if we substitute that into the equation in that form, we're going to change the y to a p. P equals k, which we don't know, a, and then, a to the, I'll do this way, pa to the t. So if we're using that basic form of the equation, so I've used the same form down here, y equals ka to the x, except I've changed it to p and t because that's what we're using in the question. Except that we know in this case that p equals 4 as long as t equals 0. So I've got 4 equals k times a to the power of 0. Now a to the power of 0, anything to the power of 0 is 1. So that's actually meaning that 4 equals k times by 1. K times by 1 is just k. So therefore we know that that k equals 4. Great. All right. Now to find out what a is in this case, we take that information we know, and we know that also when t equals 2, p equals 5.02, because that's the other coordinates being given. So we rewrite our equation again, but at this time we already know that k is 4, so we replace that. So now what we're hoping is that by doing this, it's a very bad t up there, by doing this we'll be able to work out what a is, because we want this equation to be written in terms of p and t. So we know that when p equals 5.02 happens when t equals 2. So 4a to the power of 2. So now I just have to solve for a. So the first thing I'm going to have to do there is divide 5.02 by 4. Is going to be 1.255. So 1.255 equals a squared. So obviously the next thing I'd have to do is take the square root of both sides. So I go into my calculator and I take the square root of the last answer I got, and that's going to get me 1.12. Now what did it say? I think I'll leave it at 1.12 because it's 1.120. Obviously, I might just make clear that that's the 2 decimal places. Okay, so if that's the case, then therefore the equation is in the form of p equals 4, 1.12 to the power of t. and that's our form of our equation. It's in that basic form of which is over here, of y equals ka to the x, but we've got it in terms of p because that's what our equation is for, and in t because that's what else our equation is for. So you just have to, with the exponentials, you'll always have to substitute in t equals 0 and whatever the y-intercept is to find what your k is, and then you'll have to choose whatever other value they've given you to find out what the a is in that equation. Okay, so this third question is a little bit of a nasty one because it's asking you, and this is what makes this a harder question, it's asking you to understand sort of fundamentally what's going on here with exponential growth. And what we know with exponential growth is it's very similar to compound interest. With compound interest, we're earning interest on our interest. With exponential growth, we're getting growth on our growth. So in order to work out the interest rate, we kind of use this formula, or not kind of, we do use this formula, the future value equals the present value, 1 plus r to the n. To find out what our annual growth rate is, we would need to use that equation. It's no good to look at how much it changes by in 1 year, because it's compounding, it's not following a straight line, it's not linear. So in this particular case, we know that we do have some values here. We know that the future value is 5.02. We'll use this value here that's been given to us. And that happens, so after 2 years, we've got a future value of 5.02. We start, however, with a present value of 4. We don't know what the rate is. That's what we're trying to solve, but we know that that happens after 2 years. So there's our future value. We know that a future value of 5.02 happens after 2 years, and that we start, our present value is 4. So we've now left with an equation with one bit of algebra left in it, so we should be able to solve for that. So first things first, we'll divide both sides by 4, so that we just have the 1 plus r squared, r to the power of 2 on one side. So if we divide 5.02 by 4, we're going to get 1.255. I could use my calculator, but we did that sort of up here. So we've already sort of done that calculation. So I can say that's 1.255 equals 1 plus r squared. And then I'll need to take the square root of both sides, which once again is very similar to what we just did. So we're going to end up with the same value here. If I take the square root of both sides, I'm going to end up with 1.12 ... whatever that is, equals 1 plus r. I've taken the square root of both sides. Okay, now I'll take away 1 from both sides to get r on its own, and I'm going to end up with 0.12 ... equals r. Now the question asks me to give the growth rate to the nearest percent. At the moment, I've left with 0.12 equals r, so I could finish off by saying, therefore, the growth rate is 12% to nearest percent, because that's what the question's actually asked us for. Okay, so yeah, there's quite a jump there from being able to realise that all compound interest will follow an exponential curve. So we can kind of use that compound interest formula to find out what the rate of growth on an exponential curve is. Okay, that ends that little question. If you have any more of these, please feel free to ask, or if there's anything else you'd like me to work through. And as I mentioned to the people who came in the holidays, if you need a bit of help with your maths, if you turn up when the big class would usually have maths, and try and find me. If I get put on another class, chances are that either Miss Burns or Miss Rowlands won't be. So that's when you're likely to find one of us 3 maths teachers available, is whenever those big classes are usually on. So that's that.